Okay, good day class. All right, so today we will continue part 5.1.2.3. Okay, so last lesson we have learned series expansion of the composite function, right? How to use the standard Maclaurin series to find the expansion of any function. Okay, so today we are going to see 5.1.2.3. Series expansion of the sums, differences, products, and quotient. That means that if a function involves add, subtract, multiply, and divide of two functions, how we are going to use the standard Maclaurin series to do it. Okay, number one, we may use the standard series expansion of function to find the series expansion of their sums, differences, products, and quotient. So we need to determine the new interval of convergence of the series. So it's actually similarly like this. Okay, means we are going to use the standard Maclaurin series to sub in to find the expansion of a new functions. All right. Okay, so first we will see some examples in your textbook first. Okay, before we go to the exercise, because there are not many questions. And the example in the textbook is very good. Okay, you can open your textbook. All right, page 162. So we are going to discuss example 9 to example 13. All are quite good examples, so it's worth for us to go through it. Okay, all right, look at the first example. Okay, example number 9. So you see, they say, find the Maclaurin series for ex plus e negative 3x, state the interval of convergency of the series. Okay, so ex no problem, it's a standard Maclaurin series. All right, so you can copy from the list. And e negative 3x, we are using the composite function method like we have learned last lesson. Okay, so this is the standard Maclaurin series for ex. Then e negative 3x means we are going to sub all the x become negative 3x. All right, then we expand and elaborate and we get this. Okay, therefore the expansion for this new function ex plus e negative x, so this is ex plus this is e negative 3x. Then we add the corresponding terms and simplify and get the new series or new expansion. Okay, it's just like that. Not difficult. Okay, so you see, as we know that the interval for the standard Maclaurin series ex is all real number. Okay, so as I say last lesson, if this happen, then the new interval for the new interval of convergence of the new series also will be the same. All real number for x. So it means that x can take any numbers so that this function to be valid. Okay. Okay, next. So this is summation. We add two functions. Okay, next example is division. Expand ln 1 minus 2x over 1 plus 2x as a series of ascending power of x. Find the range of value of x for which the expansion is valid. All right. Okay, so actually here we are going to use some exponential law. So we know that ln 1 minus 2x, 1 plus 2x, we can expand become ln 1 minus 2x minus ln 1 plus 2x. Okay, we use a little bit of the rules of the exponential. All right, then we see one by one. Okay, so you see 1 minus 2x, 1 plus 2x. So we know that we are going to use the standard series ln 1 plus x. Okay, so this is a standard Maclaurin series for ln 1 plus x, and the interval is between -1 to 1, inclusive 1. All right, and then so we have ln 1 minus 2x, right? So as we say, ln 1 minus 2x, we actually can write as 1 plus bracket negative 2x. So we are going to sub all the x here become negative 2x, like this, you see? Okay, then we elaborate, expand it, and simplify. So we get this thing. All right. So for this one, the interval is this. So for negative 2x, so same like what we have done before. So become negative 2x lies between -1 and 1. Okay, when we shift the x to both sides, because negative ma, so we have to change the sign. So become negative half and half. Alright? So the negative half have equal sign now. So become like this. Okay? Alright, then also see ln 1 plus 2x. So 1 plus 2x, so you are going to sub all the x become 2x into the standard Maclaurin series. Okay, simplify it, then you get this. Alright, this is the new, this is the new function, the new interval. Okay, now, what we need to do is, okay, yeah. Therefore, ln bracket 1 minus 2x1 plus x, as I say, we use exponential law to expand like this. So we have this series and we have this series. Okay, then we simplify them and get the simplest one. Alright, so this is the interval for this series. This is the interval for this series. So we have to find the intersection, n. Alright, the intersection between these two series. So this is the final interval of the convergence for this function. Alright? Okay. Right, next, example 11. Okay, so this one, they are asking to find the series expansion for e2x sine 2x. Okay, in ascending power of x up to the terms in x cubed. This one involves multiplication. Alright, so just now this one is summation. This one is the second one is division. Example 10. So example 11 will be multiplication. Alright, so ex, okay, the standard Maclaurin series ex is this one. So e2x, sub all the x become 2x and simplify it. Alright, so for sine x, so this is the standard Maclaurin series for sine x. Okay, sine 2x means sub all the x become 2x. Oh, that's it. Then simplify it. Alright, then multiply them. This is e2x multiply ex. So you have to multiply one by one. Like first term, multiply all the terms here. Second term, multiply all the terms here, and so on. Alright, but we can omit all the terms higher than power 3 because the question only 1x cubed. For example, 2x, you do have to multiply with this. Because 2x multiplied with x cubed, you have x power 4, which is not neat in the answer. Okay? So after you expand, then simplify the simplest one. Okay, this question, they never ask you to find the interval of the convergence C, but we can find it also. Because you see, for ex, the interval is all real number. For sine x, also all real number, right? So if both all real number, then the new series also, the interval of convergence C also all real number. Alright? Okay, one more. Okay, example 13. Let me see. Okay, so example 13 also multiply. Also multiplication. So you are asking to express 1 minus x squared cos 2x as a series of ascending powers of x up to x power 5. Okay, so for cos x, this is the standard Maclaurin series for cos x. Therefore, cos 2x, we just sub all the x become 2x. Alright, so we get this 3. Okay, the interval is all real number. Okay, then for the second one, alright, for the second, 1 minus x and square. So 1 minus x and square is just a quadratic. Okay, you can square it easily. You can expand it easily. First term square, second term square, and then 2 multiply this. Only 3 terms. So here you see, very important. For cos 2x is a series. So you must have this symbol plus dot dot dot. Okay, where else here no need. Because this is quadratic. So quadratic after you expand, just 3 terms only. Alright, just 3 terms only. This one no need plus dot dot dot. This one yes, because we omit the following terms. Alright, so be very careful with the plus dot dot dot. Okay, then we multiply as usual. First term multiply all these 3. Second term multiply all these 3 also. But remember, we just want x power 5. Alright, and this one also. But x squared you don't have to multiply with this one because x squared multiply x power 4 is x power 6. Not needed. Alright? Okay, so after expand, we simplify everything. Okay? Alright, next. The last example will be find the Maclaurin series for tangent x up to the terms in x power 5. So you remember in our standard Maclaurin series, we don't have expansion for tangent x, but we have sine x and cos x. Then we know that tangent x can be expressed as sine x over cos x. Then just sub in, alright, the standard Maclaurin series for sine x and standard Maclaurin series for cos x. Okay, so when involve division like this, alright, because like just now we have ln, so we can expand it. So this one no ln, so we have to do long division. Yes, be very careful when you do long division, a little bit confusing. Okay, alright, so you see, this is numerator, so remember numerator is the dividend, so put inside. Okay, denominator is the divisor, so outside. Okay, don't put in the wrong place. Okay, alright, so we start from here, right? We start from here, divided by this. So we want, same like what you have done. It's just that now we in the reverse position, reverse sequence only. Okay, so first we know that we have to eliminate x. We have to eliminate x. So you think, what going to multiply 1, then you get x. So of course x, so x multiply 1, you get x. X multiply half x squared, you have half x cubed. X multiply this one, you have 1 over 24 x power 5. Alright? Then minus them, no? So x minus x, no more. Right? So negative 1 over 6 minus negative half, so you get 1 over 3 x cubed. Okay, for power 5, also the same. 1 over 120 minus 1 over 24, negative 1 over 30 x power 5. Alright? Because the question only one x cubed, so we just stop at x cubed. Alright? Then next, to get 1 over 3 x cubed, so we have to multiply 1 over x cubed. So 1 over x cubed multiply 1, you get 1 over x cubed. 1 over x cubed multiply this one, you have 1 over 3, 1 over 2, so you get 1 over 6 x power 5. Enough. Alright, you don't have to do this one multiply with this one. No need, because we want x power 5 only. Okay, then you minus them. Okay, minus, no more. So negative 1 over 30 minus negative 1 over 6, you get 2 over 15 x power 5. Alright, then of course 2 over 15 x power 5 times 1, you get this thing. Then all at the back, you just write dot 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 only. Okay, alright. So therefore, the expansion series for tangent x will be this one. Only this. No need to write remainder. There is no remainder. Understand? Because this series is continue. So continue. So you will continue and multiply them, right? So there is no remainder. So we just write the quotient as your answer. Okay? So when involve division, yes, you have to be very careful. Okay? So these are the 4 examples that show all the types of question that can ask in this part, okay, in this 5.1.2.3. Okay, so next, I'm going to discuss some question in exercise 5.3. All right, I only will discuss 2 questions here. Okay, so question 1 is, use addition or subtraction of power series to find the first 3 non-zero terms in the Maclaurin series for the following function. Okay, a ln 1 plus x, 1 minus x. So you know, same lah. You can use the exponential law. Okay, so this one become ln 1 plus x plus ln 1 minus x. Alright, then you continue. And b also same. B same like example 10. Right? Do like example 10. Okay, for b. C also do like example 10. It's just that after you expand, this power 2 can move in front. Or after you expand, after you expand like this. After you expand like this, here. Okay, after you expand, cannot see. Okay. Okay. After you expand. Alright, after expand into this step, then the 2 move in front only. Okay? So question 1 actually Yeah, not much, not difficult lah. This one shin x. Show that shin x is actually the definite. This is not sine, this is shin. Okay, so shin x, actually shin x represent half bracket ex minus e negative x. Okay, so this is like the summation, like the first example, example 9. Okay, and cos x, this is not cos, this is cos x. All right, this is the series, this is a function for cos x. All right, so you just expand this thing only. So I want you to do question 1 or the question here as homework. All right, and question 2. Okay, question 2. Use the multiplication or division of power series to find the first 4 non-zero terms. Just now, question 1 first 3, this one first 4. All right, this one involve multiplication, multiplication, multiplication. This one division, this one division. All right. The method you can refer to the 4 examples that we have discussed just now. All right. Okay. So I'm going to discuss question 3 and 4. Then for question 5, find the Maclaurin series for EAX cos BX, where A and B are 2 constants. Seek the interval of the convergence. This is multiplication, so you can do it as a homework also. All right. Okay. So for the shin and cos, actually in your notes, I have given you some extra information about shin and cos. Remember your notes, It's at the back. Okay, the extra information that I give to you. Remember the Taylor series. Okay. About the Taylor series. About how to use binomial series. And the convergency test. All this extra information I have given you. This is a part. Okay, you can refer to this. Okay, hyperbolic definition, hyperbolic trigonometry function, which involves shin, cos, cosecant, or secant, tangent. Okay, so you can refer to this. What is this, and how we represent it by the graph. This one you study on your own, if you are interested. Okay. Okay, sorry. All right. So let's see question 3. So I'm going to discuss question 3. So the question 3 sounds like this. Alright, expand sine square x as a series of ascending power of x as far as the term in x power 8. They want us to expand up to x power 8. Sine square x. Alright, okay, how to expand this? What we are going to use? Of course, sine square means what? Okay. Okay. Sine square. So sine square, we know that it means square of sine x, right? Square of sine x. And square of sine x means sine x multiplied sine x. It's just multiplication. Okay. So this is the expansion for sine x. And this is another expansion for sine x. Okay, so yeah, I made a mistake here where I forgot. You have to write plus dot 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 plus dot dot dot. Okay, don't ever forget your plus dot dot dot. Then we expand it. So first term. So I'm going to use first term to multiply all these 4 terms. I copy up to x power 7 only, because you see for sine all are odd power, so I don't need power 9, right? Because just now the question say I just need to do it until x power 8, right? So first term going to multiply with this 4, so I get this first 4 lah. You see, I separate it so that you can see clearer. X multiply x, x square, x multiply x cube, x power 4, and so on. Then next part is second terms. I use second term to multiply all these 4. Alright, so x cube multiply x, x power 4. X cube multiply x cube, x power 6. X cube multiply x power 5, x power 8. Alright, so x cube I don't have to multiply with x power 7 because it's power 10 already, which is not neat in the question. Alright, so this is the second part. So I use a line to separate it so you can see clearer. Okay, so and then remember this is negative. So when multiply in, the sign become negative, positive, negative. Okay, then have to use the third term. The third term is here. Third term multiply first one, power 6. Power 5 multiply cube, power 8. So power 8 already. So the third term no need to multiply these two anymore because it's more than what we want already, right? Okay, so this is the third term. Okay, and the last one, x power 7 only need to multiply x power 8. You don't have to multiply others because it's more than what the question want already. Alright, so for this part, it's just a little bit complicated when you, not complicated, it's just more terms when you expand it in multiplication form. Just be very careful. Okay, then we simplify everything. Like we only have 1x squared, but x power 4 we have 1, 2. Alright, and power 6 we have 1, 2, 3. Alright, and power 8 we have 1, 2, 3, 4. Okay, so you get the answer. Okay, so remember, if you want the interval of convergency, for sine x, the interval of convergency are all real number. So the new function sine square also will be all real number, right? Okay, then we see one more example, which is question 4. Alright, question 4. Here. Wait, cannot see. Okay. Down a bit. Alright, okay. So question 4. Find the Maclaurin series of this. This division. State the range of value of x for which the series converge. Alright. Okay, so this is a division, right? First we see the denominator. Okay, so the denominator is 3 cos x plus 1. So 3, so we sub the series of cos x inside here, plus 1. Okay, for this question, they never ask us where to stop. So remember I say, if they never ask us where to stop, we give at least first 4 terms, or first 4 non-zero terms. Okay? This is very simple. So multiply in the 3, okay, then plus dot dot dot, then plus 1. That's why 3 plus 1 is 4 . Okay, we'll give the first 4 non-zero terms. Just simplify them only. Then the denominator is cos x plus 3. This is numerator, this is denominator. Cos x plus 3. Alright? So just very simple. This is cos x. Cos x is this one. Cos x is this one plus 3. So this one plus 3, 4 . So others, same. Okay? Next step. So we have to do the long division. Okay? So the function is, this is numerator, this is denominator. This is numerator, this is denominator. So this one inside here. Sorry. Okay, so the numerator inside, the denominator outside. Okay? Then we do one by one. We do one by one. So I want to eliminate 4. So what going to multiply 4? I will get 4. Of course, it's 1. Alright? So 1 multiply 4, 1 multiply half x squared, 1 multiply and so on. Alright? Then we minus them. 4 minus 4, no more. Okay, negative 3 over 2 minus negative half. So you get negative x squared. 1 over 8 x power 4 minus 1 over 24 power x power 4. So you get positive 1 over 12 x power 4. And negative 1 over 240 minus negative 1 over 720 is negative 1 over 360 x power 6. Okay, then next, I'm going to see what multiplied 4 and give me negative x squared. What number multiplied 4 will give me negative x squared? So I have to do I have to put negative 1 over x squared. Alright? So negative, because x, definitely I need x squared here. Alright? So what multiplied 4 become 1? So negative 1 over 4 multiplied 4 become negative 1. Alright? So you get this. So negative 1 over 4x squared multiply negative half x squared, you get this. Negative 1 over 4x squared multiply x power 4, you get this. Alright? So negative 1 over x squared, you don't have to multiply x power 6 because you will get x power 8, which is out of our range already. Not range, out of what the question 1 already. Alright? Okay. Then, sorry. Oh, like this, sorry. Oh, this one. Okay. Negative 1 over 4x squared, when multiply the first 3 terms, we get this 3, yeah? Sorry, we get this. Okay, then minus them. This one minus this one, no more. Okay, this one minus this one, get this. This one minus this one, get this. Alright? Then, next. What we are going to multiply 4, then I get x power 4. So, definitely I need x power 4. So, negative 1 over 96 multiply 4, I will get negative 1 over 12. 24, okay? So this is what I choose. I have to put this value and then multiply. This one multiply first one, you get this. This one multiply second one, you get this. So this one don't have to multiply the third and the fourth one because the power is higher than what we have already. Okay? Then minus 10. Okay? So this one simplified already. So this one minus this one. You see, every time have to write plus ... every time. Okay? So you remember your answer, you don't have to write the remainder. Just omit the remainder. We just need the quotient. Alright? Therefore, 3 cos x plus 1 over cos x plus 3 is like this. The quotient. Don't forget your plus ... So this is the expansion for this function. Okay, and we know that for cos x are all real number. Therefore, for this function, the interval of convergence also all real number. Okay? Alright. So, today, we just want to do until here only lah. Today, we just do until here. Okay. So, your homework will be... let me see. Okay, so okay, you see here. So your homework will be exercise 5.3. Okay, the rest is like what I say. Sorry, cannot see. Okay. So your homework will be exercise 5.3 like what I say. Question 1 all, question 2. All right. Question 3 and 4 I have discussed. Okay, question 3 and 4 I have discussed, and question 5. All right, this is your homework. Okay, now I want you to complete these 2 questions as quiz. Okay, one is 2014 question B here. All right, 2014 in your notes. Okay, the function is defined by this one. All right, A showed that this is this, and hence find the Maclaurin series. This part we have done. Okay, this part we have done. You can look back for your question, the example. This part we have done. We are using the Maclaurin's theorem to do it because when you're asking to find G prime, G prime, so show that, hence show that the Maclaurin series is this one. So means you have to use the Maclaurin's theorem. So part A we have discussed. Okay, and you get this answer. So what I want you to do is complete part B. Alright, so the expansion for this function already have lah. The answer is this one lah. Okay, then B is use the Maclaurin series obtained in A to, number 1, find the expansion of gx over 1 plus 2x in ascending power of x up to the term in x cubed. Alright, this one actually means you have to do division lah. Alright, so I want you to complete this one now. Okay, and another question is STPM 2020. Alright, STPM 2020. You refer to the past year question that I gave it to you. Alright, and also just do part A. Okay, so use the remainder time, okay, the time left to complete these 2 questions. Then by 12:20. Okay, the latest 12:30. By 12:30, I want everyone scan your answer for these 2 parts and forward it into the Google Drive, forward it into your Google Drive. Okay, so I will check your Google Drive by 12:30. Okay, huh? All right. If you have any question, yeah, you just WhatsApp me and ask. Okay, so today we will stop here. All right, and then we will continue again tomorrow. Okay, bye.